So I want to add another plane to this system right here. So we graph these two. It's kind of these triangles, and we can see that they're not going to intersect. So what if we added this other plane, x minus y equals 0? And maybe the best way to think about this is, see, z doesn't really matter, sort of, in this x minus y equals 0. But if you think of this as the equation of the line y is equal to x, and now go sit on the xy plane right down here. And where are all the points that this is true? Well, it's all the points where this is true. So let's look at that. That is going to be a straight line out of the origin, right like this. And it doesn't matter it sort of doesn't matter what z is, because well, if z is at, let's say this point up here is z equals 10, we're still only interested in where x is equal to y, and so there'd be these up here. So no matter where we are, no matter how high up we are on the z-plane, we have this plane that kind of cuts through here. Okay, I'm going to take these lines away in just a second. Maybe I should put them in a different color. So well, I'm gonna, you know what? I'll just leave it the way it is. And again, this, just like before, this plane right here goes. Let me do it in red. This plane does really go on forever. So it goes back here. But really, we're interested in where it intersects. Oops, where it intersects these other two planes. And it turns out it intersects on these two lines right here. Let me use the blue. It intersects right on this line, and again, that's just on this triangle on this line. I mean, on this triangle on this plane, but this goes on forever and ever. So I should probably draw an arrow on both ends. And it also intersects this plane. I'm going to use a different color. The plane that's defined by these 3 points right here. So it's also going to intersect this red plane, this x equals y plane. This red plane right here intersects the plane described by this triangle, and I'll do that in this same strawberry color. It intersects in a line just like this. So here it goes. It's going through the plane there, it's going through the plane there, and it's just, so it's just right on top of the plane. So these two lines are going to be parallel. And if we took this system right here, and I'll line up the x's. If we took the system and found because this system, the solution to the system is this set of two lines. I'm sorry, is not this set of two lines. You can see there's no solution to this entire system. There's no set of points that shares all of these conditions, and so the determinant would be 0. This is one of the special cases. Okay, so let's go on to this next one. So let's look at this. X minus y equals 0, x equals 4, y equals 4. Okay, so let's look at x minus y equals 0. That's the one we just did. So let me do that in strawberry. That's the one that comes out like this. And again, it goes infinitely back and forward. But I'm just keeping us stuck in this cube here because we might see the connection. What about x equals 4? Well, here's the x-axis. Let's do that in green. So x equals 4, so we're right up here. And now these two planes, look where they intersect. They intersect right on this line, right here. And what about this y equals 4? Let me do that in Cayenne. Okay, so y equals 4. Well, here's y equals 4. And it goes right through like this. And what do we have here? We have this intersection right here. What's the intersection? Again, this goes right through this blue line. So the solution, the graphical solution, would be this, right there. And it would line the line, so because these planes would go on forever, this line would come out straight, straight up and down. So that would be the solution to these three equations. Go back to strawberry. To these three equations, they would intersect right on this line. Let me thicken that up a little bit just for emphasis. Black, and here we go. So this is the solution to these three equations, and it's an infinite number of points. And you can see that if we took these two, and let's use substitution, if we took these two givens and put it into this equation, we would get 4, right? Substituting x equals 4 in for here and y equals 4 in for here, we would get 4 minus 4 equals 0. And 0 equals 0. And this is true, and this is one of the special cases where we have infinite solutions. Okay.